I'll record that. Okay. Designing a statistical study. Here are the steps. Oh, today is 9/2. All right, step 1. Identify exactly what you want to study. For example, let's say that you're trying to do a study on people's like a grip test, like how strong they can grab onto something. How are you going to do that? Exactly how are you going to measure it? Like what are you looking for? What kind of devices do you need? And making sure that it's not something that you're accidentally measuring that is not true about a person. Like just because they're super muscular doesn't mean that they have excellent grip strength. Somebody like super, like scrawny can have excellent grip strength. So making sure that you know exactly what you're going to study. Next is developing a detailed plan. The sample needs to be the same as the population. Let's say that we're trying to figure out the grip strength of Winona University College students. So you go to the gym and you do the grip strength test on like 30 kids. Does that represent the population? No, if you specifically go to the gym, then you're probably going to get people who are generally more concerned about how strong they are or want to prove it more, right? And so it's not going to be matching the population. Then you follow your plan and collect the data. Then you describe the data. This is like using math or graphs, kind of looking at what you got. This is the facts part. Then you interpret the data. To make a guess, an educated guess about the population. While this is based in facts, it is still an opinion. And the final thing, and probably the most important thing in a statistical study, is to identify any errors. It's really important to identify errors after you do something because your data might not be valid. And sometimes, like if you're just testing the grip strength of some kids at Winona State, maybe it's not that important that your data is absolutely accurate, although you probably want it to be. But if it's something like how well is this medicine working that stops heart attacks, that's really important that we have it to be accurate. All right, there are 4 ways to collect data. Simulation, survey, experiment, and observational study. Lincoln, do you remember any of these and what they are? Okay, how about you, Jocelyn? Nope.
A survey is when you go around asking people.
Right, this is asking people. It could be digitally or in person. What's the problem with asking people questions? They can lie. Sometimes on purpose, sometimes by mistake. Like if I said to you, hey Riley, how much sleep did you get last night? 7 or 8 hours. Okay, not 6 or 7, 7 or 8. Are you positive? Okay, but do you see how Riley's being pretty vague? Like he's got a pretty big window there. Like if I said, was it 7 hours and 20 minutes or was it 8 hours and 1 minute? Like you don't know because nobody's sitting there with a timer, timing, being like, and I fall asleep right now. You know, like nobody's doing that. But if you're in a study where somebody's watching you sleep, then yeah, they do know exactly how long you were asleep. So if you just ask people, people are either guessing, lying, trying to tell the truth, etc. But you can't really tell. How about an experiment? Come on, just say what you know about experiments.
Beakers.
Testing beakers. Well, I'll just write beakers down. This is a test with treatment and control group. A treatment group receives the thing you are testing. The control group doesn't receive what you're testing. Why do you need to have a control group?
Because it'll see if the treatment or the thing you're testing actually works or not.
Right, but I mean, wouldn't you just know if your treatment group gets better or something happens that's positive? Why do you need the control? Right, why do you need that comparison?
You actually look at the differences.
Right, because a control group might improve or change without any kind of treatment. Like, let's say that I was like, okay, I want to see if doing things in group projects help kids learn better, right? So I test you guys before we do it. I test you guys after. Hey, everybody's grade's gone up. Everybody is better at IXL or whatever, right? Riley, you with me? Okay, so IXL gets better for everybody doing this experiment. But also I'm just teaching you. So the other group, my other control group, I don't do group stuff, right? I just teach them. And then both classes improve at the same time. That's just me teaching them has improved. If I look at the one that did all the group stuff and they're improving more than the control group, then I can say, ooh, the only thing I did differently with them is that I did group stuff. So that is the difference. But if I just looked at them to begin with and said, oh, they've learned. Great. Well, maybe they would have learned without the group stuff. I need that control to compare it to, like you said, a comparison. Okay. Observational study is when you watch and record. You do not interfere. This is especially good with wildlife. I mean, if you're trying to figure out like the eating habits of gorillas, you don't want to like walk in there and be like, would you like a carrot? You know, like you just like watch what they're doing and see what they're doing and record it. A simulation is when it's too dangerous or costly to do an experiment. Anybody think an example of a simulation?
I would say like the meek, but they actually tested that.
Yeah, but I mean, and it was an experiment, but at the same time, they weren't like, let's drop it on a city and see what happens, right? They had like things there that they could blow up, that they could see how it interfered. That is a simulation. Because they were planning on using it not just in the desert by itself. They're planning on using it somewhere else, right? What were you going to say?
I was thinking about some stuff this Japanese unit did, but they actually did it. It wasn't a simulation.
Oh, it was an experiment.
Yeah, like how much of the human body is water.
Oh, really?
Yeah, they made it pretty similar to jerky.
That's gross.
Yeah, they waited before and after. Found out 75% of it is water.
Interesting.
Yeah.
I assume the person died by natural causes? Or for the experiment? No, okay. Crash test dummies is a great example. You don't want to put like a family of 4 into a van and drive them against a wall. Let's do it with crash test dummies. Or like seeing if like a building can withstand an earthquake. They're going to build like a model, right? And put it through the structure testing instead of being like, let's try to destroy this building that we've made. So that kind of thing. A placebo is when somebody gets a fake treatment. The mind is a powerful thing. Sometimes just the act of taking a pill will make you feel better. And not just make you feel better like if you're depressed or something like that. Like it will actually there will be physical changes in your body that can happen because you think that you're getting a treatment. So let's say that you get migraines all the time, and they give, for the experiment, they give the treatment group the migraine medicine, and the control group, they give sugar pills, which is essentially like a pill that does nothing, right? And then both groups say that their heads feel better. Well, then it's probably not the medicine, it's probably just the placebo effect that's getting them. A confounding variable is when a third option can cause a result in an experiment. This is a surprise. Not intended, not good. So let's say that I work for the hardware store, and I'm trying to prove to my boss that, like, if we put like a display thing on the end of an aisle, that people will buy things more, right? So I like put umbrellas out, and I'm putting umbrellas all over the end of this aisle, like at the end cap, and hoping that people buy them. And then shouldn't have done that. Still recording. And then that day there's a rainstorm. And I'm like, wow, people bought a bunch of umbrellas today. Is it because that I put them on the end of the aisle? Or is it because it's raining out? You know, like that's the confounding variable. It's like a surprise third thing that happens. The two things that could have happened were they're buying it because of the end of the aisle, or they're not buying it because of the end of the aisle. So that's the variable I'm thinking about. But then something else gets introduced and kind of messes up my whole experiment. That's not predictable. You can try to avoid it, but sometimes you just have to like get rid of all of your data because you realize something else happened. Blinding is when the subject doesn't know who gets the real treatment. Basically using a placebo. And by the way, does that mean that we're lying to people when we give them a placebo? No, in fact, you're required to in medical studies and other studies to say you could be receiving the real treatment or you could be receiving a placebo. You know, like you have to say that. So they know that one could be happening or the other. Double blinding is when the subject and the experimenter don't know who gets what. The subject and the experimenter doesn't know who got the treatment. are researchers biased? Some of them are, I'm sure. Like, imagine that you spend like 5 years working on a new medicine. Do you want it to work?
Yeah.
Yeah. Are you going to lie about it? No. But you do want it to work, right? So let's suppose that I'm a researcher, right? And I gave you medicine for depression that I'm hoping works. And I gave you a placebo, okay? And so then I bring Riley in to interview him to see how he's feeling. And I say, hey, Riley, how are you feeling today? Okay, and you answer my questions. And I go, hey, Jocelyn, how are you feeling today? Can you guys hear the tone in my voice, how I changed it? And it's not because I'm trying to influence what you're saying. It's because I'm expecting it to go one way or the other. Do you see what that means? So you can actually change people's responses by being cheery, being down, or expecting one thing or the other, or even interpret the data wrong. So double blinding is when nobody knows what's happening. All right. There are 6 examples here of how to select a sample. A simple random sample is you give everyone a number. And then randomly pick numbers. Stratified is when you first organize them by categories. First, separate into categories. Pick some from each. An example of that would be if I said, hey, how did you get to school today? And then I only asked seniors. A bunch of them would say, what? I drove. Is that representative of our whole school? No. So maybe I'd want to do a stratified sample first, where I took the whole population. I said, look, I'm going to ask 5 ninth graders, 5 sophomores, 5 juniors, 5 seniors. That's stratified. Cluster is usually by location. And it's asking everybody in that location. That would be like, an example of that would be me going over to Steele's room right now and asking everybody in Steele's room right now how they got to school today. It's a cluster. I'm just grabbing everybody in one spot. Systematic is ask every nth person. By nth, what I mean is fill in a number there. So like maybe you're doing like a check to see if there's any drunk driving happening, and you're randomly stopping vehicles, and you decide every 30th vehicle I see, I'm going to stop. Convenience, this is a bad technique. This is asking whomever's easiest. You should never use a convenience sample, but it is a thing that exists. For example, if I said, hey, I'm doing a psychology experiment. I'm going to ask all my friends. Like, what if I said, hey, Riley, what's everybody's favorite sport? And you're like, let me go find out. And then you just ask your friend group. I'm guessing a lot of your friends are in football with you, are in basketball with you. They probably like those things because they're in it. So they're probably going to say that. So it just always gives you a bad sample. A census is asking everyone. It's not really a sample. It's asking everyone. Okay. Example 1 and 2. Why don't you turn to your sit with your posted partner really quick? All right. So go ahead and identify what the way to select the sample is for 1 and 2 out of the 6 choices up top. Talk to your partner, please.
Is it just one answer for each, or is there?
Just one answer for each.
It's not like random.
Well, I'll follow that. See, it's separated, but but so it's a simple random systematic search. Just add. Let's look. It's gonna be systematic.
All right, you guys all done?
Yeah.
What'd you guys get for the first one? Cluster for sure. That's based on location. This is also, by the way, used a lot in like field studies. Like what they'll do is they'll set up like a grid in like a forest or something, and then they'll be like, okay, we're going to randomly select this 5-yard by 5-yard grid, and then we're going to look at everything inside of it. How about this one? Systematic. All right. We're going to finish the rest of these tomorrow, except for this calculator bit. So go grab a calculator. I'm going to show you how to use the random number generator on a calculator. So I just need to realize that my son is probably going to turn into you, Riley, because the amount of just random noises you make. Because my son is constantly making random noises. That's just how he goes. All right, so everybody write down instructions. You're going to hit the math button first. You're going to go over to probability. You're going to pick on mine it's the 5th option, random integer.
Oh, isn't that how you pick your number things?
Yep. All right, that'll put this on your screen. Once you have it on your screen, show your partner that you have it on your screen. What'd you say?
You get it?
Is that power?
Probability.
Sorry.
It's roll over.
See, this is why we check with each other.
Something to do.
All right, then you're going to put in the low number you want, and then the high number you want, and then how many. All right, so let's all select somebody from in here. Let's say that Ms. Langworthy is number 1, I'm number 2, and then Riley's 3, 4, 5, and 6. Okay? So let's all try it right now. My lowest number is 1, comma. The comma is above the 7. My highest number is 6, comma. And let's say that you want to get 2 people. I got number 4 and number 2, which is myself and Lincoln. What'd you get? 6 and 6. So you can have repeats. So often when you're using this to select people for a test, which we will be doing a lot of experiments in here, where you get to actually ask other people stuff and you get to go around the building and do any kind of experiment you want. If you get repeats, you just take the first different number. How about you, Jocelyn?
4 and 2 or 4 and 1.
4 and 1?
4 and 4.
4 and 4. Oh, doubles.
1, 6.
1, 6. So if I wanted to really get 2 people, I'd probably put like 4 in here, and then I would just take the first 2 different numbers. By the way I did that so fast, just in case you're interested, is you hit second, enter. Hit second, enter. It pops up the last thing that you just typed in the screen, and then you can just change any number you want in it. That's really helpful if you like are doing a long equation or something and you mess up just a little bit. You don't have to type it all again. Okay? All right. There's no homework for tonight. We're going to stop for the day. You've got 3 minutes left of class.